Good afternoon, students. In the last lecture, we have already studied the concept of UCM and its meaning with their examples. Now here, UCM means the motion of any particle or any object revolving along circumference of circle with constant linear speed or constant angular speed. Such motion of particle is known as UCM. During UCM, the direction of linear velocity changes at different point along the circumference of circle, but angular speed of body remains constant. Let us see about the applications of UCM. There are mainly two applications. First application is that any vehicle or any car moving along horizontal circular track, the actual figure like this. Let C be the center of circular track, R be the radius of circular track, and the dot represent the center of gravity of a given vehicle. Here the force of static friction acquired along the vehicle directed towards the center of circle along the radius during centripetal force. We already know that the centripetal force F equal to mr omega square, or is equal to mv square by r. This is the mathematical form centripetal force. Due to this force, any vehicle, it is in motion, but here the force acting on vehicle directed towards the center of circular track because of motion is UCM. But we have to explain the maximum speed of any vehicle along the given horizontal circular track. Then assuming RB radius of circular track, CB center of your road, and weight of that vehicle W is mg. But there are two types of forces. The force acting vertical downward, that's nothing but weight of given body, W equal to mc. And the second force, which is known as normal direction N, exerting on the given vehicle from the center of gravity of a given body vertically upward. Then both are balances to each other. Then we can write normal direction N equal to weight of a vehicle. Therefore, N equal to weight of body mc. Suppose this is equation number 1. During the motion of any vehicle along a given horizontal circular track, the another force, centripetal force, which is known as static force of friction directed towards center, then Fs equal to, is known as Cpf, is equal to mv square by r. This is relation number 2. Then dividing by equation 2 by 1, then we get Fs upon n equal to mv square by r divided by mg. Then solving, m cancel, we can write v square upon rg, that is equal to Fs by n. But in this application, the centripetal force, it prevents the vehicle from outward slipping or skidding. That skidding term, it means that the force prevents the vehicle from outward slipping or outward push from the road surface. That means the vehicle do not thrown off from the road surface due to Fs. Therefore, equation 3 clears that the speed of vehicle increases, static force acting on body also increases. That means Fs direct to speed, as v increases, Fs also increases. But here, according to the law of static friction, Fs directed to normal direction, and F is equal to mu s n, where mu s is called as coefficient of static friction between the tire and given road surface. Then that value of Fs substituting instead of Fs in relation 3, then relation 3 becomes mu s n divided by n equal to v square rg. Here dividing n by n, it is cancelled out and we get v square equal to mu s rg. Then taking square root on both the sides, we get v max equal to under root mu s rg. This is required formula to calculate maximum speed of given vehicle moving along horizontal circular track due to centrifugal force. अशा प्रकारे एखादं जर व्हेकल किंवा एखादी कार हॉरिझॉन्टल सर्क्युलर ट्रॅक वरती जर सर्क्युलर मोशन मध्ये जर मूव्ह होत असेल तर त्यावेळेस त्या कारच्या सेंटर ऑफ ग्रॅव्हिटी पासून डाऊनवर्डला त्या कारचं टोटल वेट आणि अपवर्डला असलेली त्या कारच्या बॉडीवरील नॉर्मल ट्रॅक्शन दोन्ही इक्वल असतात आणि इक्वल असल्यामुळं ते व्हेकल डू नॉट एस्केप आउट फ्रॉम रोड सरफेस. तर रोड सरफेस पासून बाजूला फेकलं जात नाही. याचाच अर्थ देर इज नो एनी ऍक्सिडेंट. कुठल्याही प्रकारचा ऍक्सिडेंट या ठिकाणी होणार नाही आणि त्या व्हेकलला गती प्राप्त करण्याचं काम त्या व्हेकल वरती एक्झर्ट होणार एफएस म्हणजे हा स्टॅटिक फोर्स ऑफ फ्रिक्शन असतो आणि त्या स्टॅटिक फोर्स ऑफ फ्रिक्शन हा एक प्रकारचा सेंट्रिपिटल फोर्स असतो आणि दोन्ही जर इक्वल केलं तर आपल्या या ठिकाणी त्या व्हेकलचं मॅक्सिमम स्पीड v max that's equal to root of mu s rg. Using this formula we can calculate maximum speed of any vehicle along horizontal curve road surface. Then for a numerical we can take the values of mu s, it is known as coefficient of static friction. R is the value of radius of curve road and g is accident due to gravity. Putting these values and taking root, we get maximum speed of that vehicle measured in meter per second. That's all.